This is Lab 9, Example 1. We want to use the parent function y equals f of x to find the following parts a and b. We are given the parent function that looks like this, where I've marked out what this point is here. And we are given for a graph that looks like this, where there has been some kind of transformation that has taken place from the parent to graph A. And we want to figure out what the function graphed in A is. So the way we're going to do that is we're going to determine how this graph has changed from the parent graph. So in the parent graph, I'm just going to switch these two over. In the parent graph we have this point here that is circled. And it doesn't look like there's any vertical compression or vertical stretch or any kind of stretching that's happened either horizontally or vertically. And there's been no reflections over the x-axis or the y-axis, so we can directly see that it's probably just a vertical and horizontal shift in some way. So to determine what those shifts are, this point is at -5, +5 is what it is, and it has changed to now be -2, +3. So we know that in the horizontal direction, which again is the x-axis point, -5 and -2, it has gone to the right 3 spots. So this point right here has gone over 3 spots. So it's gone right +3. And then vertically we can see that it's gone down. And it's gone down from 5 to 3. So it's gone down 2. So it's gone down -2. So we're going to look at our transformations, and our vertical upshift is y equals f of x plus k, vertical downshift is y equals f of x minus k. So we have a down -2. Since it's gone down vertically, we're going to use this pattern right here. So this is going to be in the pattern of y equals f of x minus 2. So instead of k, we have our -2. And this right here, right +3, is going to be a horizontal right shift. Y equals f of x minus h is that pattern. So this right here is going to be y equals f of x minus 3. Like that. So it's opposite between horizontal and vertical, the signs are. So because of that, we're going to combine these two, since it's done both in this graph. And so so the function graphed in A is y equals f of x minus 3 minus 2. So if you graphed y equals f of x, it would be giving this, and if you graphed out this, it would give you this right here. Moving on to B, we can get away from that A graph now. We want to describe how the graph of y equals f of x plus 2 plus 1 can be determined from the parent y equals f of x and then graph it. So here we're doing the opposite from A. A, we were giving a graph and told to figure out what the function is. Now we're given a function and we need to figure out how to graph it and how it can be determined from the parent. So here's the parent. And it looks like from the pattern we have, so from y equals f of x plus 2 plus 1, we're going to look at the patterns here that are given in our function, in our transformations. And it looks like we have some type of vertical shift. So we have a +1 right here, that's outside of our function. So it looks like there's a +1 right here, plus k. So we're going to have a vertical upshift of +1. So vertical up +1. And then it looks like we have something happening within the function here, +2. And that's going to be some kind of horizontal shift. So if we look for that pattern, we see we have a horizontal left shift, y equals f of x plus h, because there's a plus there. So we're going to move left 2 spaces. So we're going to go left 2. And that's how it's going to change from the parent function. So we're going to move on to graphing that. So graphing that. We have our parent function here for reference. this point is going to move, and we're going to start with this left point right here that's circled, and we're going to move it up 1 and to the left 2. So we had negative 5, 1, 2, 3, 4, 5, up 5, 1, 2, 3, 4, 5. This was the original, and we're going to move it up 1, so we're going to go up 1 and to the left 2, so back 2. So now the point is over here. And we're going to do that with each of these 4 points. So this point was at negative 1, positive 1. So it used to be here. I'm just going to do small dots for the original. And now it's going to move up 1 and left 2. So you're going to do that for each and every single one point. This one was at positive 2, up 1. So it used to be right here. And you're going to move it up 1 and back 2. So I'm doing the bigger dots for the smaller dots are for the original, bigger dots are for the transformed. And for this last point that was at 3, 3, so it used to be 3, 3, so that was original. It's now going to go up 1 and to the left 2. And then we can simply draw our lines, connecting all the big dots. And now we have successfully graphed our function y equals f of x plus 2 plus 1.